Good morning. My name is Matthew Yates and I'm from the School of Medical and Applied Sciences at Central Queensland University. Today we're going to examine the effect of antagonist pre-stretching on agonist force and power, a review of the literature. Now traditionally, stretching improves performance. We've all seen this in some way, whether it be by ourselves, whether you go for a run or go to the gym. Generally when you warm up, you'll do some stretching. Otherwise you'll see teams play sport on the TV perhaps. Whenever you see these people doing their warm-ups, there's generally stretching involved. However, recently, stretching decreases performance. This is what's been proven in literature. So we know that stretching is commonly performed as part of the warm-up, and a warm-up is designed to affect temperature of the muscle, to decrease stiffness, and increase nerve conduction. So we all know that warm-ups are very important. More specifically to the topic today, we're going to discuss antagonist and agonist muscle relationships. So we can see with this diagram to the side, the top picture, we're looking at a bicep contraction, so a bicep curl. In this scenario, the bicep is the agonist muscle and the tricep group is the antagonist muscle. So to relate that to our study today, we're looking at the effect that pre-stretching on the tricep would have on force and power of the bicep. So research has shown that stretching agonist muscles prior to power efforts may reduce braking effort. So this would mean that there'd be more power generated. So in this scenario, there will be more power generated by the bicep if the triceps are stretched correctly. However, there are only minimal studies conducted on stretching of antagonist muscles, so the minimal literature that is available appears indecisive. Further findings could affect performance, could affect overall performance if it leads to having an efficient warm-up. For our methodology, the databases used for the study were PubMed and the National Strength and Conditioning Association. The key words used were stretching, force, power, antagonist, and agonist. So the search restrictions were articles published in the previous 10 years in order to get the most relevant studies. All the articles were peer-reviewed. We got the full text availability, and obviously all articles were in English. All of this literature was assessed and categorized into our findings. So our initial search results showed that we got 35 articles, and from these 35 articles, only 7 articles were selected for this review. So the reason why there was such a big cutback in articles was because we wanted to stay true to the specific topic question, and that was that we're only concerned with articles that involve stretching of the antagonist muscle and how that affects the agonist muscle. So a lot of these articles that came back in the search criteria were very general and referred to different forms of stretching. For example, how static stretching is different to or better than dynamic stretching. So we wanted to go that little bit further and focus on the antagonist-agonist relationship. So of the 7 articles we selected, 4 reviewed that we had increases in performance, 2 reviewed that we had decreases in performance, and 1 article reviewed that it was neutral with no change in results. So this is depicted in the diagram to the side here too, so we can see that just over half of the articles that we reviewed were involved with increased performance. For a more specific look at our findings, we observed different methods of testing. So some methods involve isokinetic testing, isometric testing, and even an EMG. We observed different stretching methods throughout these reviews as well. Some had static stretching, dynamic stretching, and even proprioceptive neuromuscular facilitation. But most importantly, the most important section from the findings were that the methods tested different movements. So by that we mean some used jump squats, some used isometric tests, others used upper body exercises, so they were all different. And so onto our discussion now, you can see we've split up this section into 3 categories: the articles that increased in performance, the articles that decreased in performance, and the articles that remained neutral. So for the ones that increased performance, a similarity between these articles was that static stretching was used across all. Of the 4 studies, 3 of the 4 were all used on lower limb testing. So for our first movement was vertical leap. So the first study on that, Sandberg, Wagner, and Willardson and Smith in 2012, it was the use of static stretching on the hip flexors, which was then used to improve performance on a vertical leap test. To our second study, which was Wakefield and Cottrell, that was in 2014. Their study was extremely similar in that it was static stretching again on the hip flexors, and that was used to increase performance in a vertical leap. And the final study on the vertical leap was Winters in 2004. Now notice the date of this study. It is outside of the criteria that we originally set upon. However, when we came across this article, the methodology was exactly the same as the 2 that have been reenacted in 2012 and 14. So we decided to include that as well. So that showed static stretching of the hip flexors, which led to improved performance of the vertical leap. On to the next set of increases, it was isokinetic peak torque. So it was a study by Sandberg using a dynamometer leg extension test, which is done at 60 degrees per second and then again at 300 degrees per second. So the static stretching of the antagonist muscle was the hamstrings, and that showed improvements in isokinetic dynamometry. For the decreases, once again, they were all static stretching used for those articles. They were all lower limb exercises as well. So the two exercises there were isometric squat and isometric leg extension. That was in the McBride study. That showed that performance decreased when they used static stretching prior to exercise. For our second study there was the vertical jump used by Simic, Sarabon and Markovic in 2013. That showed that there was a decrease in performance when the static stretch hold was less than 45 seconds. So the conclusion from that article read that static stretching as a sole stretch was to be avoided. And then for our neutral study, this compared static stretching, dynamic stretching and PNF. It was all lower limb. It was a study on indoor soccer players, and it used EMG activity to calculate their results. So it was the static stretching of the vastus lateralis and the rectus femoris, and it showed that there was no difference in performance. So to further our discussion, we can see that credible studies have proven results. Pre-stretching antagonist muscles improve force and power of agonist muscles, so this is evident in the majority of the studies that we've looked at. However, because there is such a minimal research available at this time, it is difficult to make a decisive decision. However, in the future, we hope that more literature can further support these current findings. And to conclude our topic, research regarding warm-up is always popular and useful. It can be used for any sporting team, any individual athlete if it's regarding to increase performance. So from the minimal findings available, we can see that performance did increase when using static stretching. So that's something we can take away from this study. However, we would like to see more research concerning one specific movement or one specific demographic. We noticed that a lot of the articles that we assessed today were talking about different movements or using a different demographic of people. If we could get similar movements studied on similar demographics, we may be able to progress further in this study field. So for an exciting future research regarding these topics today, personally I'd like to see, it would be very exciting to see studies done in vertical leap and running or short sprint times, as I feel that these movements can easily be carried over into the majority of sports and physical activity we see today. Thanks very much for listening.